Okay, in this section, we're going to be exploring all kinds of different ways to display data after collecting it. So basically, we're going to be working with different types of graphs, and some are better than others, depending on what kind of data you have that you're working with. There are two major kinds of data that we're going to be talking about, and the first one is categorical data. I don't know why my pen is not working very well today. And categorical data is data that represents objects in groups or categories such as male or female, months of the year, etc. Anything that you can use that you can put into a category. But that's why it's called categorical data. The second kind we're going to be dealing with is numerical data, and numerical data represents numbers of some kind. So whenever you take measurements like, measuring rainfall or measuring the length of something, or, how many seconds it is in between thunder and lightning, or something like that. That would be numerical data because you're doing stuff with it with the numbers. Okay, let's talk about pictographs first. These are going to be our first types of graphs that we're going to look at. And here we have an example of a pictograph. And if you'll notice, a pictograph is exactly what the name says. It's pictures. So, and each one of these has to have a legend. Here's our legend over here. It's very important because it has to tell us exactly how much each one of those pictures is worth. For instance, in this pictograph, each one of these pictures is worth 10 kilograms. So here for the month of July, it looks like we have 10, 20, 30, 40 recycled newspapers. Okay, now there are a few drawbacks to using pictographs, and part of those are something like you see here in September where we have a partial picture. That it's very, very difficult to represent, a quarter of a picture or a half of a picture or three-fourths of a picture, because we can't see precisely exactly what that is that we're looking at. It makes it much more difficult to interpret the data. So that's a drawback to using pictographs, and not that they don't have their place, because they do, but just you want to make sure that you have nice whole data pretty much when you're using pictographs. Okay, let's look at another way about how we could even come up with these pictographs to begin with. I said, well, usually we create what we call a frequency table, and we're going to see frequency tables a little bit later on also. But this is an idea of what a frequency table looks like. Um, we create this to help us see exactly how many of each picture that we're going to need. And frequency, I said frequency tables are not limited to just pictographs. They're also useful in other types of graphs also, and that is very true. So here we have probably gathered some data, and we found out that we have these teachers here and the number of students in each one of their fifth grade classes. Well, you see these numbers are all nice numbers. They all end in 5. So when they did their pictograph to represent it, you see that here we have each one of these figures represents 5 students. So now we have 5, 10, 15, 20 for Ames, which makes sense, and 20 for Ball. Again, that matches our frequency table. 5, 10, 15 here for Cox. So the frequency table is a way of laying out your data so that you can create the pictograph that will help you visualize it. Another type of graph that we can use is called a dot plot or a line plot, and this is what one looks like right here. These graphs use X's above a number line to show how closely together or how far apart our data is. If you'll notice in here, we have a lot of distance or a big, huge gap between this data value right here, which is at about 52, and this data value here, which is at 70. So we call this 52 one a outlier because it's way far away from the rest of the entire data set. We can also see whether they're clustered together, as we can see here, or if there are any gaps. Here's an open gap between these two data values here. Another thing that these types of graphs are very good for us to see is, if I can erase that off of there. Let me see if I can erase that off of there. There we go. Another thing that they're really good for helping us see is the mode. And the mode just represents the most times that any data value appears. In this case, it would be 82 right here because we have that showing up 4 times. That score, because these are scores on a test, that score happens the most times. So obviously then we would call that the mode of our data. Okay, another type of plot that we can look at is called a stem and leaf plot. And let's see what one of those looks like. This is a stem and leaf plot right here. This is actually more of the legend of it. This is the actual stem and leaf plot. And stem and leaf plots use an initial digit as the stem and then the following digit as the leaves. So we would call this part of our plot the stem, and we would call this part of our plot the leaves. So the way we would read this is this number would represent 52. This number here, this would represent 70, and then we would also have 72, and then we would have another 72, and then a 73, and a 75, and so on and so forth. This is the same data that we saw before in the dot plot, but it's just listed in a slightly different manner. And you'll notice that the number that's in the tens digit, that's what we're using for our stem, and the number that's in the ones digit, that's what we're using for our leaves. And here again, we can also see some important information from this type of graph. We can look to see which general area the scores were most closely in. We can see that more students made an 80 something than any other category on this test, that more students made in the 80s, and then the next highest amount of students made a C, and that there were 4 students that made A's. So this is a very nice way of being able to look at that data. Okay, sometimes you'll want to compare stem and leaf plots, and we call that a back-to-back stem and leaf plot. So here we have similar data. We're talking about their class test scores, but let's say we wanted to talk about her second period and her fifth period class. We could create those stems. Again, this would be our stem, and then we would have leaves for each one of the classes. So that would be a leaf, and then over here would be leaves also. So for instance, we would say that in the fifth period of Abel's class, there's a 52. In the second period of this person's class, there's a 50 and also a 52. Do you see how that's read? Okay. So that is a back-to-back stem and leaf plot. Now sometimes we've talked about in the past that we have to do a frequency table. This is a really good way of being able to tally up data. Like for instance, Um, we might have had a here are the ages of their presidents at their death. So this may have come in a long list. And what we've done is we've created sort of categories here, that ages 40 to 49, and then went through the list and found each time that happened and made a tick mark. And then at the end of, being of finding all of those data values and put them in their correct place, then we can add up the frequency, add up those tally marks that from 40 to 49. There was evidently two presidents that died in that age range, five presidents that died in the age range of 50 to 59, and so on and so forth. So now once you have that frequency diagram or a frequency table, you can do a lot of different stuff with it. A lot of different types of graphs are formed off of those frequency tables. So we're going to see a couple of those here. Let me flip the page. For instance, this is exactly what we saw a while ago. We had the age from 40 to 49, and there were two of those. And if you'll remember, there were five from 50 to 59. What we've drawn out here is called a histogram. And a histogram is, you can look at it as a bar chart. And in fact, let me go down here, and you can see this is actually a bar graph or a bar chart. The only difference between the two is a histogram, there is no space in between each one of the bars. That's what makes it a histogram. A bar graph, if I move that down here, here's a bar graph. You notice that we have spaces in between each one of those bars. That's what makes it a bar chart. I also want you to notice here, right here we have a little squiggly line. That means that something has been left out of the scale here, and we can see our scale. There's just no way that we have enough space in between here to go from 0 to 40, and then we go all the way over here to 99. This means that there's part of the graph that's been taken out or that is missing. So we always make that kind of jagged line to represent that. And it shows up again here in this graph here where we have from 0 to 130. There's some tick marks missing in between here, so we make that jagged line to represent that. Now you can also have what's called double bar graphs, and that helps to show more than more than one category at once. So let's get an idea of what that looks like. This is a double bar graph here, and again we have to have a legend that has to tell us exactly what it is that we're looking at. So this lighter colored green is later presidents, and then the darker colored blue would be earlier presidents, and they didn't seem to make a distinction of who was later and who was earlier. So I would probably, if I were going to be doing this graph, I would want to make sure and list out, what I meant by later presidents. You know, um, you know, presidents after 1920 or something like that. Earlier presidents being those before 1920, something like that. You really want to make sure that you label everything so carefully and properly, because that's all you have is looking at these graphs and being able to interpret them is what's written out here. So notice that each one of our graphs always has a title here, and also that each one of our graphs has a the axes are labeled. I almost forgot the word there. Our axes are labeled. Let me erase that off of there. Because people have to be able to understand what it is that they're looking at. So here are the lighter green was the later presidents, the darker blue representing the earlier presidents. So that shows you two different categories at once within that same range. Now there are other kinds of bar graphs out there. Some of them are used more often than others. This percentage bar graph is probably not used as often as you would think, um, but they've taken a single bar and they have listed each one of their categories: dress, flip flops, Crocs, loafers, and tennis shoe. See, those are our shoe types here, and they've changed their frequency over to percentages and then blocked off the bar by percentage. So, like half of the bar would be 50%. So this tennis shoe being 48 is just a little bit less than half of the bar itself. So in a way, it's kind of like a pie chart, which we're going to talk about here in just a second. But you don't see these very often, but that's called a percentage bar graph when you do see one like that. We also have what are called stacked bar graphs, and they look like this. And that is where your data is literally stacked. You have two different types of things you're looking at, but rather than put the bars right beside each other, you stack them up on top of each other. So it's a little bit harder to see, I think, but there are times when you do use a stacked bar graph, so you need to be aware of them anyway. Okay, and last but not least, we have circle graphs, or what we used to call pie charts. These graphs take a circle and they cut that circle up into sectors that represent how much of the whole circle your data represents. It's kind of comparing it to the whole. So, for instance, here this is depicting U.S. population by age in the year of 2008. So we can see that 33% of the population here was 21 to 44 years old. 26% of the population here was 45 to 64 years old. Each one of these colors represents a different age group. And again, what they have done is they've taken that frequency table and changed everything over to percentages and then blocked off that corresponding percent of the circle. So 26% is just a little bit more than a quarter. So this would be just a little bit more than a quarter of the circle. 25% together, these two sectors together are 25%, so they are exactly a quarter together of the circle. And then it's broke down even further into a smaller percentage and then 20%. Now another couple of examples of pie charts would be something like this, and I just want you to notice that in each one of these, again, our legend is so important, that and also your titles and what it is that you're working with. You've got to make sure and label everything completely in these graphs. Otherwise, people won't know what it is that you're talking about. So here again, we have another pie chart or circle graph where our data has been changed over to percentage form. And this has to do with the Titanic, actually. I didn't get the full part of the explanation in here. I just wanted you guys to be able to see the graphs really well. So we had, these are people who survived and then people who died on the Titanic. And this first, second, third is class: first class, second class, third class, and then, of course, the crew. So very, very interesting that we can pull out that kind of information and look at it in a circle graph form.